giving birth to a larger brained, larger headed offspring is downright dangerous. And today there's mortality that takes place with mothers and offspring in humans because it's actually kind of a hard thing to do to give birth to a big brain baby. So how does this work? If evolution will just kill off this practice because it's not possible, all you have is the structure that you're born with, and this is coming from a primate background. So you have the pelvis of a primate. What happens is that there's sort of some compromises that are made, some half measures that natural selection makes. Now, we've talked a little bit about this in terms of human development. Humans have a very long childhood, and this allows the child to become socialized and become successful in the group. But that's also the part of the reason why we have such a long childhood is because we give birth earlier. So we actually have a shorter gestation period for our size, our anatomy, but we also have to accommodate the biomechanics of our upright walking and having a larger brain as a consequence. So we actually kind of give birth to half-baked potatoes. The result is that this infant is helpless, but then you can socialize it and make that brain develop outside of gestation. The other thing that we've noticed is that in humans, the human birth goes to the infant or the offspring, the child goes through the birth canal in a corkscrew motion. It twists around, and we can see that Australopithecus was getting a big enough brain that may have been uncomfortable during birth, but rotational birth like this was not present yet. And so what we're starting to see is that in Homo erectus, this rotational corkscrew motion is probably starting to become present. And so as the brain gets bigger, other parts of the anatomy also have to adapt, but also other processes like when you give birth also change. Also from Africa, we have some other evidence from about 1.5 million years ago in Kenya, a site called Ileret is where we found some more fossil footprints. And these are basically indistinguishable from modern human footprints, which demonstrate that it's not just the foot bones with the double arches, but that Homo erectus was using their feet in nearly the same way as we were. So we see that evolutionary development continues in Africa, and so Homo erectus doesn't vanish from Africa. It's still there, and it is developing. And in the Middle Pleistocene, from about a million years ago, Tim White and his team in Ethiopia found what we call the Dhaka skull, and this skull is very interesting because, as we're going to see, one of them called slightly later called sorry, I'll come to that in a second. It looks very much like the Homo erectus that we start to see emerging outside of Africa. We'll come to how that happens later. So from about a million years ago, from about 1.8 million years ago to about 1 million years ago, we have consistent features that are seen in development of Homo erectus in Africa. And so Homo erectus seems to have come from Africa, stayed in Africa, developed in Africa, but it did more than that, as we will see. Also, there's a later species from the Middle Pleistocene in Ethiopia from about 600,000 years ago, so much more recently, that sees some changes, and its brain size is within the range of modern humans. And so the African Homo erectus continues to stay in Africa and develop. But as I said, it's going to do more than that. So this Bodo skull we're going to come back to in the next chapter too. Interesting thing about Bodo too is that it looks as though there are some cut marks on Bodo's skull, which means that after Bodo died, another Homo erectus defleshed it. So does this mean that they were doing something ritualistic, or was it cannibalism? We don't know. There's no chew marks on it, but certainly it was defleshed after death. So Homo erectus evolving from about 1.8 to about into 600,000 years ago or later, was in an environment that we understand to have been sprawling savanna grassland environment with some patchy wooded areas. There were large predatory cats, monkeys, some of the ancestors of modern zebras, giraffes, elephants, hippos, rhinos, warthogs, African rodents, a large number of antelope species. So there's a lot of meat out there. And as we're going to see, Australopithecines were waiting to take advantage of some other creature killing these species of meat-bearing animals. Homo erectus got tired of waiting around, and it appears as though Homo erectus was making better use of this environment, which with a lot of meat resources around, big open plains where they could chase it down, and so that body type becomes important. So if you, with a big brain, can come up with a tool that can wound an animal, no primate is going to be able to run down an antelope at full health. A cheetah might be able to, but they're even fail a lot of the times. We're not fast enough. But what we are good at is long distance running. Humans are. And with the same body type, we can presume that Homo erectus was also very good at long distance running. So if you can wound an animal and you can just follow it for long distance, eventually it will panic, it will start to get exhausted, and you will eventually get it. So it appears as though this focus on meat eating started to become the primary survival strategy for Homo erectus. Now, what happens to big herds of animals? Well, they move around, right? They're not like plants. You can't just stay in one tree and eat the leaves as they grow. If you are trying to hunt down herds of animals, they're moving sometimes vast distances across big open landscapes. And if you want to eat them, if you want to catch them, you've got to follow them. And so we saw that in Africa, Homo erectus from about 1.8 million years ago continued to stay in Africa, but some of these Homo erectus started to follow herds outside of Africa. So for the first time, hominins start to appear outside. And this was a big surprise that we found just a few decades ago. The earliest known Homo erectus fossils from a site called Dmanisi in the Republic of Georgia. This is between the Black Sea and the Caspian Sea, and it was in the former Soviet Republic of Georgia, now the Republic of Georgia, an independent country. And Dmanisi has turned out to be one of the, it's kind of a hot spot. And they've had several skeletons, including 5 skulls, one of which is shown in your book, with capacities between the 600 to 750 cc range, which incorporates both Homo habilis and Homo erectus. But they had body types like Homo erectus. So it appears as though some early, when I say early, I should say this dates to 1.7 million years ago. So Homo erectus appears in Africa about 1.8 million years ago. By 1.77 million years ago, so 30,000 years later, we are all already getting Homo erectus outside of Africa in Asia. So these long legs are on the bodies of the Dominici Homo erectus. And so we're putting them into Homo erectus category, even though they had slightly smaller brains, but it appears as though they were some of this first wave of Homo erectus development, some of which stayed in Africa, some of which moved outside of Africa, probably following hunted animals. Since Dubois was working in the late 19th century, other paleontologists have gone back to the island of Java and found many more fossils of Homo erectus, including more than a dozen partial skulls. One of which is shown here is Sangaran 17, which has a brain of 1,000 cc's. It's not so that's where you would expect a sort of a mature Homo erectus to be, not quite a human, but larger than any ape or Australopithecus. It has a sagittal keel from its chewing, not a sagittal crest again, but from its the bending of the forces of the it creates a sort of an osteoblast from chewing with your front teeth, which may be from biting meat, in fact. But interestingly, I mentioned before that the Dhaka skull from about 1 million years ago is a pretty similar time period to when Sangaran 17 is, and the skulls are actually the one that Dubois found as well. They look very similar. Now, go back to your principles of evolution. If you've got a hot spot in Africa and you've got a hot spot in Indonesia, and you have development of Homo erectus over here in Africa, I guess from your perspective, Africa over here, Indonesia over here, and they're both developing in the same way, and you find them actually going through different developments in the same way. What are the mechanisms of evolution? Remember those? Those are natural selection, mutation, gene flow, and genetic drift. Now, if both of these look the same in both of these locations through time, what are we talking about here? Even though we don't have all of the connections between these two, we can assume that there was genetic drift taking place. These two populations look like they're the same populations, which means that there must be a kind of an unbroken chain of mating of these species between the African versions and the Asian versions. Even though they came from Africa and moved away, that must have filled in all of that gap. So even though we don't have fossils in all of these places that we're looking, we can assume that there were Homo erectus that stretched right across and even into the islands of Indonesia. Next, it appears as though about 1.7 million years ago, from Majuanggu in China, and then from about 1.2 million years ago from Gongwangling, and one of the earliest fossils of Homo erectus found a little bit later than the Indonesian one was what's called Peking man from Zhoukoudian in China. The one from Gongwangling in the 1.2 million year old one has a brain size of about 800 cc's. And this Zhoukoudian cave site is extremely important. Now, unfortunately, in World War II, I think it was, the entire fossil collection was lost. No one knows where those fossils were, but thankfully some scholars in Germany had asked for casts to be made and shipped to them, so the entire collection was cast and shipped to Germany, where amazingly they still exist. So we don't have the original fossils, but we do have the plaster casts that were made of them, and that's an extremely important resource because there were at least 40 individuals from this cave. It appears as though this was excavated in the 1920s and 30s, Zhoukoudian locality in China. It was a particular cave, and this is what we call Peking man. And this dated from about 750,000 years ago, and existed for about 500,000 years. And there's a lot of evidence for stone tools and, importantly, controlled fire. So it wasn't just stone tools. That we can imagine that there were organic types of tools that don't survive, but also they were manipulating other forces of nature, not just stones, but fire itself. Now, fire has a few advantages because fire allows you to get more nutrition out of certain food sources like meat, but also other types of vegetation. If you're a generalist and you have a broad spectrum diet, that's really helpful. Also, some types of foods are only they're poisonous or undigestible unless you cook them. And so cooking allows for more types of food to be accessed. Also, if you're living in a cave site, it lights up the cave so you can use it as protection and you can stay there at night. But also it keeps predators and other animals away from you to keep you safe and keep all of your food stores safe. So there's more advantages to the brain than just making a stone tool. And then lastly, it appears as though Homo erectus started to emerge in Europe. And from about 1.2 million years ago in Spain, there's a very important site called Grandolina, and Cima de los Huesos is a portion of the Grandolina sites, dating to about, Grandolina is about 900,000 years old. And it appears as though there were some, while we're talking about genetic drift between Asia and Africa, it appears as though some differences are starting to take shape in Europe. And this may be, especially in some of the later periods, because we start to come into the ice ages. And we'll talk a little bit more about that next chapter. It is a open question as to whether the European examples of Homo erectus should be thought of as a different species. Some call them Homo antecessor. But by that same token, the African Homo erectus are sometimes called Homo ergaster. So I want to simplify these things for you, and we're talking about the same basic emergence of a Homo erectus. They're all related to one another, and some look like there's gene flow going between them, and in other locations like Europe, it looks like they're starting to drift apart a little bit, maybe because they are facing some different environmental conditions that the others don't have to face. So in Africa and Asia, these are relatively warm weather environments that we're experiencing here. There may be a little bit of drift taking place in China, in Zhejiang Cave, where they have to deal with a slightly colder weather. And then in Europe, it appears as though there might be a possible drift taking place into what's called Homo antecessor. But let's just call these all Homo erectus from different localities, meaning different challenges and having natural selection forces on them applied in different ways. So, what was their behavior like, and why do I think that they're so important? Well, very important aspect is the tools that we do know about. One of them was what we call the Acheulean hand axe. This comes from a site in France called Saint-Acheule, where they were first discovered, and the spelling of that is Acheulean. And Acheulean, typically known for their hand axes, represent a cognitive shift in this hominin species. So Australopithecus, Garhi, Homo habilis had been using tools that looked and performed like things that appeared in nature. Everybody's seen a broken twig. So making a pointy stick that looks like a broken twig isn't a huge leap in logic. Cutting your foot on a sharp rock is something we could all do by accident. Replicating that with your brain takes a little bit of a leap, but it's not a huge doesn't require imagination. The Acheulean hand axe is what we call a biface, and it's carved completely in the round. So it's usually about that thick, about as thick as your hand, and there is nothing of the original rock that exists that's left behind. It is a 3D sculpture. It has removed every trace of what the original rock looked like, and it creates something brand new. Now, is it qualitatively sharper than any other sharp stone? No. But what it represents is that Homo erectus was using their brains in a way that no creature before had ever done. And that was to close their eyes and to imagine a tool and then pick up a rock and say, I'm going to make that tool out of this rock. That tool in your mind has never existed in real life before. That's what I mean by removing all traces of the original stone, the cortex as it's called, and creating a 3D object. The way I like to sort of compare this to is that Michelangelo, when he was finished carving the statue of David, was asked, how did you do this? He said, well, all I did was get rid of the parts of this marble that wasn't the statue. A little bit arrogant, but that is precisely what Homo erectus was doing, is that there was a pebble, a cobble of some sort, and their tool was inside that cobble somewhere. They imagined it, and all they did was just take all the stone parts that weren't their tool away. That requires imagination. Now that's using your brain in a different way. You're not just replicating something that exists in the real world, you're creating part of the world to what you imagine in your brain. Now, this allows you to problem solve, right? So, although hand axes are used to both cut and scrape meat from carcasses, we know that these were used for this because they're found and associated with carcasses that have been processed. We know how they were cutting large butchered animals. Homo erectus was not a carnivore, but they also relied on tubers, nuts, berries, other foods to survive. But they also likely shared everything amongst themselves because they